8M7, Lesson 18, Applications of the Pythagorean Theorem. Today, we are simply going to do some problems that basically test your knowledge of Pythagorean Theorem, other rules of triangle formulas, and it adds a bit of critical, critical thinking into the mix. So there's no obvious way how to do any one of these problems. You're just kind of tested on your knowledge of the Pythagorean theorem. Some other rules that you're going to need to know to accomplish and succeed at this lesson are: one, the area of a triangle, and that's the area, and I'll just remind you, you should know how this, the area of a triangle, you should have this memorized by now, is a half of the base times the height. You're going to need to know the perimeter of the triangle. That's just you add the length of the three sides. And the Pythagorean theorem. So I think, a squared plus b squared equals c squared. I'm not sure that you're going to need to know. Well, you need to know the area of a rectangle. Area of the rectangle, which is length times width. I don't know. There may be another formula or so, but I'll let you know when we get there. You should have these memorized anyway. These are building blocks that you're expected to take forward into high school and to know this year as well. Okay, so I'm going to give you 4 problem types. All of these problem types are ones that you get in this lesson. And so here's a type of question. I have, and this I think is the first one that you actually do in today's lesson, Lesson 18 in class. You have a space that's 28 square yards. So you have this area, this area here. It is a space that's 28 square yards. It might be a garden. And on one side, it's 4 yards long. This side's 4 yards, and you don't know how long this side is. The question is, how much fence is needed to enclose this space? So how much fence do you need to buy this, plus this, plus this? What is the question is basically, what is the perimeter of this space? That's the question that you're trying to answer. So how can we find this out if we know the area is 28, one side is 4? Well, in this case, you can't use the Pythagorean theorem because you don't know the length of 2 sides, but you do know this area thing. So that's kind of our first clue. We're going to need to use area and height to find this other length. And once we find this length over here, then we can use the Pythagorean theorem to find this piece over here. So we're going to have to do 2 steps. One, we're going to have to apply the area formula. And 2, then we're going to apply Pythagorean theorem. So if that gives you any hint, I encourage you to pause and try. Or if you remember how to do this from class, I encourage you to pause and try and solve this problem. Now I assume that you're back. I assume you're back now. So let's see. Let's apply the area formula. Well, the area is equal to a half of base times height, where this is the base and this is our height. So let's plug in our numbers. Well, 28 equals 1/2 of the base times 4. Well, the half of base times 4 can be rewritten as a half of 4 times the base using our commutativity. We can multiply in any order, so that equals 2 times the base. So if 28 equals 2 times the base, divide both sides by 2, and we get the base equals 14. So the base is 14 yards. So now let's apply. Now we have 2 sides, so we know that we need at least 18 yards of fence, but how long is this last side? Well, let's apply the Pythagorean theorem and go 4 squared plus 14 squared equals c squared. Well, 14 squared is equal to, as we know, 196. So we get 16 plus 196 equals c squared. Well, 196 and 16 is 2, carry our 1, 1, carry our 1, 2, 212. So c squared is equal to 212. So c is equal to the square root of 212. So that's the square root of 212. And we can simplify that because that's equal to the square root of 4 times the square root of 53, which is equal to 2 root 53. So that's 2 root 53. So either one, this is not simplified, and this is simplified. Now, what is the square root of 212? Because we're going to go to the store and say how much fence we want to buy, and we can't say we want 18 yards plus the square root of 212 yards. We have to tell the guy. Well, let's solve this really quick. What length of fence? We need 4 plus 14. We need 14 plus 4 plus the square root of 212, or 2 root 53. So that's 18 plus 2 root 12. That's the exact amount we need. But you can't go to the store and say, I want 18 plus 212. So we have to estimate. And then we're going to buy a little bit of extra fence and make sure we have a little bit over. Well, the square root of 212 is between what two numbers? Well, it's between the square root of 225, which is a perfect square, and the square root of 196, which we just remember is 14. So the square root of 212 is between 14 and 15. So we're going to use the number 15, and we're just going to go to the store, and we're going to say we want 18 yards plus 15. So we want 18 plus 15. So we want 33 yards to enclose our area. Okay, so that's how you do this problem. Hopefully you followed this well. You hopefully did this in class today and did a great job. Now the second question is this one. How much material is needed to cover this tent? So what is this tent? This tent is a pop-up tent, one that you might bring to a picnic. And you have this side, which is 5 feet long, this side, which is 5 feet. You got these sides that are all the same length. All 4 sides are equivalent. So you have this side up here, it's a big triangle, and then you have this side, this piece of that side, which is a rectangle. And you know that you have 8 feet from here to here and 1 feet from here to here. So you have this triangle area here, or this rectangle area right here. But then you have this triangle area up here. And notice I give you this hint that you could drop this down here and you could form a right triangle where this is half of the length of 8, this is your 5, and this is your unknown height. Okay, so I want you to pause and think about this. Pause and think and try, and then I will come back and solve. Let's use a nice bright pink. That's or purple. That should probably show up really nicely on this tent. Okay, I assume you're back. So what we're going to do is we're just going to find this side here, and then we're going to multiply by 4. That's our strategy because we have 4 equal sides. So this side is a rectangle, and that first, so it's a rectangle, and then plus a big triangle. So on this rectangle, we have 8 feet. It's length times width, which is 8 times 1, which is equal to 8 square feet of material for the rectangle piece. Now, this triangle piece, we have to think about it. I helped you divide it up here. So this part here, if we think about it, this part here is half of this length of 8, so this is 4. So we have a 4. So we have this triangle. Let me draw it again for you like this. So this is 5. This is 4. And then this piece up here is unknown right now. Well, let's see. We can use our Pythagorean theorem to say, well, we get 5 squared equals 4 squared plus b squared. So that's 25 equals 16 plus b squared. So you get 9 equals b squared. So b equals 3. So b is equal to 3. So this piece here is equal to one triangle with a height of 3 and a base of 4. So the area of this guy is a half of base times height, which is equal to a half of 4 times 3, which is equal to 6. So this here is equal to 6 square feet. So if you add this one and this one, this whole side is equal to 12 square feet. So the triangle is equal to 12 feet squared. So our total for 1/4 equals 20 square feet. Right? This is 1/4. This whole piece here, I'll just now shade the whole thing in. That's 1/4. We have another one over here, another one over here, and another one on the back. So our total is 4 times 20 equals 80 square feet. We need 80 square feet of material to cover this whole pop-up tent. So good. We are moving along. Hopefully you got that one. You know what? In case you got that one, we'll put a happy cat down for you. Well done. Now, let's go. This is a reminder from the last lesson. How far is it on the coordinate plane from -3, -2 to 7, 7? So what you're going to need to do is draw this on the coordinate plane and then answer. So I want you to pause, draw, think, remember, and solve. Okay. I assume you're back, so let's give this a go. So let's draw our coordinate plane. We don't have to do this exactly because we can, I'll show you why. We can go, well, -1, 2, 3, -2. So this here is -3, -2. And let's go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And over here, we have 7, 7. So if you remember back to lesson, this is all about lesson 17. Lesson 17, which is the Pythagorean theorem on the coordinate plane. So what do? We drop this down like this, and we take this over like this. And then we're going to find this distance C using the Pythagorean theorem. Well, how far is this side from here to here? Well, this is 7, and this here is -2. -2. So that distance is 7 minus -2. So that's 9. So this distance here is 9. You could have also counted it off. 1, 2, 3, 4, 5, 6, 7. And then counting down 2 more, 8, 9. This over here is 7 minus -3, which is equal to 10, which is 3. This is 3 from here to here, and this is 7 from here to here. So that equals 10. So how do we solve this? Well, we go a squared plus b squared equals c squared. This was the whole lesson 17. So we get 9 squared plus 10 squared equals c squared. 81 plus 100 equals 181. So c squared equals 181. So C equals the square root of 181. And that is a prime number. It cannot be divided by 3, 5, 2, 7, 11. Nope. There we go. There's our answer. That's nice and simplified. Okay, final problem. We want to go from Sheila's house to Ruth's house. Which is the shorter route and by how much? Do we want to go A? Do we want to go down Almond Street and then Berry Street? Or do we want to go straight down Chelsea Street? All right, I want you to pause and try. And be sure to do some thinking. Okay, well, the shortest distance between, you've heard this, the shortest distance, or maybe you haven't, between 2 points is a straight line. So indeed, going down Chelsea Street will be the shortest direction. But how much shorter? Well, let's figure it out. Well, we know that this is a right angle. That's a right angle. Should have drawn that in. So the distance down Chelsea Street is going to be 2 squared plus 3 squared equals the distance down Chelsea Street squared. Well, that's 4 plus 9 equals C squared. So C equals the square root of 13. Well, let's see here. So the square root of 13 is between 3 and 4, right? Because the square root of 9 is less than the square root of 13 is less than the square root of 16. So this is square root of 13 is between 3 and 4. And we know going this way is 5. So the Almond plus Berry route, this is 5 miles. And we know this is between 3 and 4 miles. So this is shorter. But by how much? Well, what is the square root of 13? Well, we know it's between 3 and 0, so we have to do our other thing where we go, well, is it 3.0, 3. Well, let's see. Well, what's 3.5 squared? Is that more or less than 3.5 squared is equal to 12.25? Well, that's not 13, so we got to try 3.6. Well, 3.6 squared is equal to 12.96, so it's got to keep going. 3.7 squared is 13.69. So 13, square root of 13 is between 3.6 and 3.7. So we can say it's between 3.6 and 3.7. So it's about, if it's at least 3.6 and at most 3.7, it's about between 1.3 and 1.4 miles shorter. Right, that makes sense. If it was 3.6, it would be 1.4 miles shorter. If it's 3.7, it would be 1.3 miles shorter. So it's somewhere in between those two distances if you went up down Chelsea Street. So the difference between 5 and these numbers is between 1.3 and 1.4. So we'll let that be a good enough answer. You could have typed it in on a calculator and said, well, 5 minus the square root of 13. 5, and I'll do that for you, 5 minus the square root of 13, and you would have said, oh, well, the answer is 1.394 ... miles shorter. Right, and that's right within our estimate. So good, we are now done. I just gave you 4 problems that were kind of like ones that you did in your chapter. These are all just applications, again, of the Pythagorean Theorem. And we're going to move in from 19, 20, 21, and 22. We're going to start learning more. We're going to go back into volumes. We're going to learn about volumes of pyramids and cones and circles, and using a little bit of geometry that we've learned over the past few lessons with the Pythagorean Theorem, and doing some really cool geometry stuff. So we'll get excited about that, and we'll see you again next time with lesson 19. And enjoy your night, enjoy your day, enjoy your life. Happy cat, happy math.